All right, today section 2.4 is going to feel like a lot of review, in my opinion. We're just kind of pulling ideas together to use postulates and diagrams. For our warm-up, what is the measure of angle ABC, Caleb?
60 degrees.
It is 60 degrees. How'd you get that?
I added 40 and 20.
Good. So it is 60 degrees, and when it says by what, it is by the angle addition postulate. The angle addition postulate allows us to add two angles together to get a larger angle. All right, our vocab today, sure, vocab is a fine word to use. A line is perpendicular to a plane. If and only if the line intersects the plane at a point and is perpendicular to every line in the plane that intersects it at that point. Now that's a little wordy, but the first thing I want to talk about is the word perpendicular, because I thought that was a word that we were all going to be good with, and then that quiz happened. What does perpendicular mean, Ataya?
When two lines intersect at a point and make a right angle.
Good. The right angle part is key. So if it's perpendicular to a plane, what it means is that it's making a right angle with any line in that plane. Okay? So if I were to drop a piece of string from the ceiling and it's just hanging straight down, assuming that this building is level, then that piece of string would be perpendicular to the ceiling. It would be forming a right angle all the way around it with the ceiling. Does that make sense? Same thing if I were to tape a ruler to the floor sticking straight up. That ruler would be perpendicular to the plane that is the floor. It'd be perpendicular all the way around, making a right angle. Another common example would be something like a flagpole, like the one out on Central Terrace, perpendicular to the ground, assuming that your flagpole is straight up out of the ground and that your ground is level. I don't believe any of these postulates are really something new. We're just going to kind of compile them into a list. Also, remember what it says, not what number it is. These numbers, 1, 2, 3, 4, 5, they don't mean anything. This is not postulate number 1. If you go to a math professor at a college and say, postulate number 4 really helped me out in geometry, they're going to have no idea what you're talking about. Okay, remember what it says, not what number it is. The ruler postulate states that the points on a line can be matched 1-to-1 with real numbers. That's something you've been dealing with in Algebra 1, possibly before. A number line is basically all that is. Segment addition. The segment addition postulate states that if B is between A and C, then AB plus BC equals AC. We've dealt with that before. You add two small segments together to get the big segment. The protractor postulate. The rays of the form OA can be matched 1-to-1 with real numbers. Not something we've dealt with just yet. I would just have it in your notes for now. We'll come back around to it when we need to. The angle addition postulate is the one that states if P is in the interior of angle RST, then the measure of angle RST is equal to the measure of angle RSP plus the measure of angle PST. That's like what we saw in the warm-up. Take two small angles, add them together, you get the bigger angle. All right, Number 5, through any 2 points exists exactly one. Anybody know it? Through any 2 points, we can put exactly one line. One line. Related to number 5 is number 6. A line contains at least 2 points. Gotta have 2 points for a line. If 2 lines intersect, then their intersection is exactly one what? Point. 1 point. 2 lines intersect, there's 1 point. If you want to be drawing little pictures by these, you could. You don't have to, but you can if you want. Through any 3 blank points, there exists exactly 1 plane. Careful. Nope. They can't be on the same line. So they have to be 3 non-collinear points. If we had 3 collinear points, we can't guarantee that there's a plane. It's just a line. So we've got to have 3 non-collinear points for a plane. The related idea to that is number 9. A plane contains at least 3 non-collinear points. If 2 points lie in a plane, then the line containing them lies in the plane. Two points are in the plane, the line containing them is also in the plane. Number 11, if 2 planes intersect, then their intersection is a line. Very good. That statement above the diagram. When interpreting a diagram, only assume information about size and measure if it is marked in the diagram. So that means things about number measurements, the right angle boxes, things like congruency from tick marks or arc marks. Things have to be explicitly given to you in the diagram somehow. We get those blanks filled in? Okay, so let's go back to what we can and cannot assume from the diagram they gave us. Well, something we could assume about all of these points. All of these points are coplanar. So all points are coplanar. That's something that we can see and know and assume. They're all in the same plane. Are there any points that we know for sure to be collinear? A and what? D. Well, any 2 points would always be collinear, so give me more points on that line. Any 2 points are always collinear. So how many points do you think I want you to give me? 3 or more. C, J, E, sure. You could say C, J, and E are collinear. Remember, on some diagrams, they don't always put a dot at an intersection point because we have a postulate that says if 2 lines intersect, they intersect at a point. So they don't always put the dot there. If you want to go over and put dots at your intersections, you can do that. C, J, and E are collinear. Okay? What about a pair of angles that are a linear pair? Do we have any linear pairs? We actually have a few linear pairs.
BA.
So remember to name angles. We have to use how many letters? 3 letters. We can't use 1 letter because there are multiple angles at the same vertex. So give me really any angle that you see here, and I bet we can find one that's a linear pair to it. Which one? AHB. Why does it have to be AHB? H is the vertex. Vertex always has to be in the middle. Okay, there is such a thing as an angle that would be ABH. They just don't have it labeled there. They don't have that angle drawn. So which angle would be a linear pair to AHB? BHJ or BHD. That would work. If you want to put J or D, it doesn't matter. They both go out that way. Do we have vertical angles here? I'll go ahead and tell you we do. Vertical angles occur anytime we have 2 lines that intersect each other. So let's, again, give me an angle to start with. Majay? HJC. Okay. HJC. And which angle is vertical to HJC? EJD. Good. So we can assume things like linear pairs, vertical angles. We can also see that line AD and line BF intersect where? Careful, 2 lines intersect at a point. They intersect at point H. You don't have to put the word point. You could just put they intersect at H. So these are all things we can assume. Now, it seemed like maybe some of us were struggling a little bit with naming these angles. So that's something that maybe we need to work on, is naming angles from a diagram. I'll be thinking about that. Things that we cannot assume. We cannot assume that points G, F, and E are collinear. We can't assume that. Why not? There's no line between all 3 of them. You can always put a line between 2 points. You cannot assume that there's a straight line through 3 points unless they put it there. Kara.
I have one for the next.
Okay, what do you think?
I was thinking that line C, E, and BA, like they're not perpendicular.
Very good. We cannot assume lines to be perpendicular. So we cannot assume that line CE is perpendicular to line AD. Okay, same thing with BF. We can't assume it's perpendicular either. We cannot assume that lines BF and CE are parallel. We cannot assume lines parallel unless we are told it or we can prove it, which we will get into in a later chapter. We cannot assume angles are congruent unless there's a reason for it. Okay, so for example, we cannot assume angle AHB congruent to angle HJC. The only time you could know that angles are congruent is if they are vertical. Okay, we can tell vertical from a diagram and vertical angles are congruent, but if they're not vertical and they're not marked somehow, we can't assume that. Okay, we don't know that BF and CE are parallel. We also don't know that they intersect. So we cannot assume that BF intersects CE. We don't know one way or the other if they will or will not intersect. That's not told to us in that diagram. All right, let's jump into some examples. State the postulate illustrated by the diagram. Remember, we're not looking for numbers here. We're looking for actual postulate statements. I'll tell you, what do you think?
Through any non-collinear points exists one plane.
Good. Through any three non-collinear points, there exists one plane. Through three non-collinear points exists one plane. That's all I want you to do. Match up the pictures to the postulate. We ready for 2? Okay. Which postulate allows you to say that the intersection of line A and line B is a point? Disagree. I tell you, what do you think?
If two lines intersect, then their intersection is every 1 point.
Very good. If two lines intersect, their intersection is exactly 1 point. If two lines intersect, then their intersection is exactly 1 point. If it helps when they give you that information, you could draw yourself a little picture, like line A, line B, intersecting at a point. Anybody need more time or have questions on that one? Okay, moving on. Use the diagram to write examples of the following postulates. So now they're giving us a postulate. We are using the diagram to give a specific example of it. So a plane contains at least 3 non-collinear points. So let's start by naming one of our planes. Which plane do you want to talk about? Plane Q. Works for me. Bless you. Plane Q contains... So now, what do they want us to list? 3 non-collinear points. So what non-collinear points do we see in plane Q? V, Y, and W. You could say contains points V, Y, and W if you want. You could reiterate the fact that they're non-collinear, but we should be able to see that in the diagram. That's all they're looking for. Take that postulate, give a specific example from that diagram. That was not our only option. We could have talked about, that might have been our only option this time because they didn't put 3 points in plane P. So if they'd put more points in plane P, we could have also used that one. All right, let's move on. If 2 planes intersect, then their intersection is a line. So they first want us to list how many planes? 2 of them. What are our 2 planes? Planes Q and P, we want to talk about their intersection. So those planes intersect where? Line B. Their intersection is exactly one line. In this case, that is line B. Questions, concerns, example 3. Okay, next up, our favorite type of problem. Sketch a diagram showing segment RS is perpendicular to line TV intersecting at point X. Okay, so we know we need a segment, we need a line, we need them to intersect at point X, and they have to be perpendicular, which means they meet at a right angle. So you can kind of choose what you want to start with. I'm going to start with my line TV. Better make sure that we get it marked. RS needs to be perpendicular to it, and RS is a segment. So here we go. RS is a segment. What do I need to do to make sure that we know that these are perpendicular? We can't assume it from the diagram, Kobe. What do we need? We need to what? We will need a point, but the point doesn't help us show perpendicular. We gotta have a right angle box in there. Gotta have the right angle box, otherwise we don't know that they are perpendicular. Might look like it, but we don't know it for sure. We do need to label this point here. What do we need to label it? X. They intersected at X. And I do like to put the dot. You don't have to at an intersection, but sometimes it's nice. This is not the only option for a sketch. Okay, the sketch could have somehow been turned or rotated. We could have had RS going side to side, TV going up and down. We could have made it at an angle. But however you have it, you should have them perpendicular, marked with a right angle box, intersecting at point X. Example 5. Which of the following statements cannot be assumed from the diagram? First statement, E, D, and C are collinear. Can we assume that? Yes, that's fine. That one's good. Smiley face by it, whatever you want. Little check mark. Okay, the intersection of BD, line BD, and line EC is D. Well, let's look at that. So the line BD is this line here. Line EC is this line here. Do they intersect at point D? Yes, they do. That's fine. Smiley face, check mark. That one can be assumed. Can we assume that lines BD and EC, those same two lines, that those are perpendicular?
Yes. No.
We don't know if that's a right angle. It might look like it. We might want it to be one. But did they tell us that that was a right angle? No, they did not. That could be 89.9 degrees. So this one we cannot assume. Cannot be assumed. Big frowny face. Can't assume that. Can we assume that line EC is perpendicular to plane G?
No.
Once again, they did not give us any what? Right angle boxes. They don't give you right angle boxes. You cannot assume it. So that one's another big frowny face. Can't assume it. All right, sketch a diagram showing the given information. Now, if you are asked to sketch on a quiz or a test, I am going to be picky. Meaning, These need to be what kind of objects, A, B, and B, C? They need to be lines. That means that they should have what on their ends? Arrows. If you don't have arrows on them, I'm not giving you points. Okay? They also need to be marked clearly. So, I'll just start with line AB. Okay, I'll put my point A down here. Notice that I put a point or a dot by that letter. In previous assessments, some people just put a letter, not with a point. You gotta have the point there. There's my point B. Okay, now my other line also goes through point B. So I'll drop it down this way. Again, put the arrows. And then on this second line, I also need what other point? C. Now, my diagram isn't perfect. If you were to take a protractor to that, it might not measure 90 degrees, but I want it to. So what am I going to put in there? A little right angle box. I'm going to say I did my best. That was supposed to be a right angle. So even if it doesn't look like it, now you know for sure it was supposed to be. Now, on a quiz or a test, I'm not getting out a protractor, but if you give me two lines that go something like this, and then you try to draw in a right angle box, I'm not going with it. Are we clear on that?
Yes.
It should appear that it's close to an actual right angle. I'm not going to get out a protractor and measure it, but if it obviously isn't even coming close, or if we go the other way and you try to do it down here, okay, that's not a right angle. It's just not. Okay, so let's make good sketches. All right, line M bisects segment ST. I would recommend starting with your segment ST. I like my sketches to start with a line usually going straight across or straight up and down. They don't have to. If you wanted this to be at some sort of slanty angle, that would be fine. Notice that this is a segment, therefore it does not have what on the ends? Arrows. Also notice that it does not extend past my endpoints. That was another issue that we ran into on that first test. Segments should stop at the endpoints. Line M bisects it. What does that mean? Goes through the midpoint or straight through the middle. So I don't really care how your line M gets drawn in. What I'm going to care about is that it goes through the middle somewhere, that it is a line, meaning it has arrows on it, that you label it with a little M, either towards the top or the bottom of it, italicized, cursive, lowercase, something, okay? But how am I going to know for sure that this is a bisector, John? Okay, anybody else know how I can tell my diagram viewers for sure, Itea? It might help. It might help to have the point labeled. But how do I know that that point's in the middle? Look. There we go. Add your congruent marks. I'm not getting out a ruler to check. So you got to tell me, I mean for these two pieces to be congruent. You need those little tick marks on there. It's not enough for it to look like it or be close to it. You've got to have the tick marks on there so that I know for sure it's in the very middle. Or if you really wanted to, you could label them with numbers. You could say these are both meant to be measuring 10. That is a very uncommon way of doing that, so I wouldn't expect it, but I'd probably still give it to you. All right, letter C. Segment LN perpendicular to plane A, and plane A bisects segment LN. There is a lot going on here. Drawing planes on a flat surface is not always my favorite thing, but here we go. So, nope. I'll start with my plane. It's not going to be perfect, but there it is. And then I'm going to have segment LN perpendicular to it. So let's go there. And then this piece of it, whoop, from here on out, we're technically going to kind of be behind. So I'm going to make it dashed as best I can, which is not great, until we come back out the bottom side of it. Then you can kind of make it solid again. But this is a segment, so at my ends I should have it labeled. So one side should be L, the other side should be N. It might help you to go ahead and label that point where it meets the plane. What do you want to call it? Nobody knows.
Call the point or call the line?
Call the point. I heard A. Okay, we can use A. We're naming that point there where it touches the plane. Now, first of all, I need this line segment to be perpendicular to the plane. So what sort of symbol should I be putting in there somewhere? A right angle box. Now that looks a little weird in a plane because we're used to it connecting down at the bottom for another line. It's not going to if it's in a plane. It's just going to be a little box floating there. The other thing that we need is for plane A to bisect LN. That's going to be a little tricky to mark in the diagram. You can technically use your little congruence marks, or you could make a note off to the side that what two segments are congruent. Which two? LN is the whole big segment. I want to talk about the two little ones. Okay, LA and AN, or NA and AL, however you want to talk about them. You could make a little statement off to the side saying, I want these to be congruent. Okay, diagrams, I understand, are tricky because there are a lot of little details that we have to pay attention to. Questions, concerns? Okay, the big things to remember would be to always use right angle boxes and little tick marks if you want things to be right angles or congruent, perpendicular or congruent. Your homework you should have on your assignment guide. It should match what's on the board. If not, let me know.